Hey class, sorry, it's early. This is Miss Norwood, and we are going to start applications of ellipses today. And then, we do also have the parabola, so we're going to kind of mix those two in. It would be best if you have a printer to print out the worksheet that I posted. If you don't, you can just, copy this down on a piece of paper. All right, so the first problem is, I don't know if you guys remember, but when you watched that little application of ellipse video I wrote on the very first day of ellipses, I showed you guys the Museum of Science in Chicago. They built a room in the shape of an ellipse so that people could use it as a whispering gallery. It's pretty cool. You can just look it up if you want to also. So what we're going to do is we're going to kind of draw that, but we want to draw it so that it works with an axis. So what I recommend is you go ahead and just drawing an axis like this, and the room is not like a complete ellipse, okay? Obviously it has an elliptical top like this, okay? And then of course the bottom of the ellipse is like not seen, but it would be down there. So using semi-ellipses is really common in this class. The equation is not different. It's just like if you were to solve for a height, you would get a plus and a minus, and if it's an ellipsoid like with just the top, you just wouldn't use those negatives. So the equation is still going to be exactly the same as it was before. Okay, so just to remind you, the equation of ellipse is this. Okay, and for an ellipse, this is actually kind of nice. It makes it a little bit easier in the parabola in the sense that you're always going to put the center of the ellipse at 0, 0. So right here, this is the center, okay? You're never going to move that. There's just no need for it. So the ellipse is a little bit easier than the parabola in the sense that the center is always going to be 0, 0, which makes HK 0, 0, which makes your formula look like this. Okay, this is when the center is 0, 0. So whenever I ask you to do something in an ellipse, draw an axis and put the ellipse center on the origin. Okay, so it says the Whispering Gallery in Chicago is 47.43 long, okay? So, and is in the shape of an ellipsoid. Okay, so the 47.3 is all the way across. So 47.3 goes all the way from end to end. This, in the equation, the number underneath the x is the distance from the center to a vertex. So it's this, okay? So if all the way across is 47.3, then you would just simply, of course, divide that by 2, and you get that that value right there is half, which is 23.65. Okay. All right, so again, this is 47.3, so this is half of that. In the equation, the distance from the center to a vertex is the number that you put underneath the x, okay? So now I know I have x squared over 23.65 squared, okay? In order to write an equation, I need to know how tall it is. So I need to know this. How tall is my room? Okay, well, they didn't give me that information, but they did give me something important. They gave me right here that the distance from the center of the room to the foci is 20.3. So if you were actually doing this, like going to this place, that's where you would stand if you wanted to hear people, okay? So 20.3 from the center, that's like almost out here. That would be a focus, and this would be your other focus. So you would stand here and you talk, and your sound waves would go like this, okay? And they would all hit so that this person could hear you. It's pretty cool, okay? All right, so if you remember, the distance from the center to the focus is the variable we call c. And there's an equation that says a squared equals b squared plus c squared. So we know a, we don't know the height, but we know c. Okay, so I want you guys to grab a calculator, type in 23.65 squared, subtract 20.3 squared, and that'll get you b squared, okay? So b squared equals 147.234. If you square root that, you get 12.134, which means that my height, this right here, is 12.134, okay? In your equation, just to be consistent, this one I wrote as something squared, so I'm going to write this one as something squared also. But of course, whoa, just dropped my pen. Hold on. Of course, you also could have just put in this number. So this number is this number right here. Okay, so hopefully you understood that. Go back and watch it again if you need to. So that's an example of a problem where you're given the focus, you're given one of the widths, and then you need to find the height. Okay, the next problem, let me move it up a little bit, is about our cool pool table. Okay, so it says, where would you place a ball so that when you shoot, oh, I wrote shot instead of shoot. When you shoot, the ball would be guaranteed to go into the hole. Okay, so here's the deal. There's the hole right here. Okay, I don't know if you guys can see it. And you want to place your ball right here so that if you shoot, it goes in the hole. If you shoot here, it goes in the hole. If you shoot here, it goes in the hole. Okay, so what would this be called right here? Okay, this and this, hopefully you realize, are the two foci. One of the foci is the hole. The other foci is where you would put the ball to shoot. Okay, all right, so basically the answer is you would put it at the focus. Okay, but obviously I want you guys to tell me where exactly would I put it. So in this problem, it tells you that the pool table is 4.5 feet wide and 4 feet like tall or long or whatever. Okay, and then so what you want to do is you want to redraw your axis like this. Draw yourself a pool table. Okay, and this whole thing, like right there, that whole thing is 4.5. But what you really want to know is you want to know like how far is it from the center. So you just take 4.5, divide it by 2, and you get that it's 2.25. So this is 2.25. Okay. All right, because this is 4.5, so that's half that. Okay, it says this is 4, which makes this 2. Okay. We actually have enough information right now to write an equation, although it doesn't actually ask for that. What it asks for instead is where would I put the ball? So we know you have to put it here and here at the foci. Okay, so how do you find the distance to the foci if you know the other two variables? Well, of course, you use this equation. Okay, the long one, so remember this is the big variable, so the biggest variable in this problem is 2.25. The smaller one is 2, and this is going to help me find the distance to the foci. Okay, so if you pick up your calculator and you do 2.25 squared, okay, and then you subtract 4, you get that c squared equals 1.0625. Okay, square root that, and you get 1.03. Okay. So the answer to the problem is you would put the ball 1.03 feet from the center. Okay, and then the hole would also be 1.03 feet from the center. Okay. Okay. All right. Ooh, I just fit that in. Okay. All right. So we're going to do one more problem today. This is a pretty typical problem where you have some sort of bridge or tunnel or whatnot. Okay. And they ask you to write two different equations. Okay. One, that it's an ellipse, and one that it's a parabola. Okay. So this will be good practice for our parabolas too. Okay. Hold on. Trying to get it straight here. There we go. Okay. All right. So this problem says, here's, I just kind of pulled a tunnel off from the internet. It doesn't, necessarily elliptical or parabola. I just wanted you guys to have a cool picture of a tunnel. So a tunnel has a span of 20 feet. Remember, span means how wide at the opening. So this is the span. Okay. And a height of 30 feet means the tallest height is 30 feet. It says, assume the tunnel is semi-elliptical, write an equation. Okay. So remember, anytime, hold on, I'm trying to find my highlighter. Okay. Anytime you see the word semi-elliptical, okay, you're going to want to draw an ellipse, okay, and you always put the center right here. Okay, so this is the center. Okay, nice thing about an ellipse is that is never going to change, okay? So this is an ellipse. It's obviously a half of an ellipse, okay? It has a span of 20, so this is 20, and it has a height of 30. Okay, it says write an equation of the tunnel. Okay, all right, so this problem is pretty fast. Okay, you know the center is 0, 0, so this is your equation. Okay, this is because the center is 0, 0, so the HK part kind of disappears. Okay, all right, A is the distance from the center to the edge in the X direction. So if this is 20, that means this is 10. So in this direction, it's 10 squared. Okay, underneath the Y is how tall is it? Well, we know it's 30. Okay, so that's the equation. Okay, if you prefer, you can square those and write x squared over 100 plus y squared over 900 equals 1, but it just doesn't matter. Okay, so ellipses are pretty friendly. Like that's all you have to do for that. Okay, parabolas are a little bit harder. Okay, and when you do a parabola, you do have a little bit of choice as to where you put your vertex. Remember, it's not called the center, it's called the vertex, but you want to put it so that it's not underneath the ground. So what you don't want to do, okay, is you don't want to put your tunnel here, because then every single value you get is underneath the ground, and you don't want to put it over here, because then every x value is negative. So the two options are you can put your 0, 0 here and draw your tunnel here, or you can have it go kind of in the middle. I am going to draw it like this today, and then maybe I'll do it differently the next time. Okay, so this is the top of my tunnel, so this is called the vertex. Okay, remember it's not called the center. Okay, and then the dimensions are still the same, so this is still 30 and this is still 10. Okay, whoa, sorry, I just hit my camera. All right, so and then if you remember, the equation of a parabola opening down, okay, is x minus h squared equals negative 4ay minus k. So that's the equation of a parabola opening down. We know that the vertex is 0, 30, which is right here, because this is 30. So we can go ahead and plug that in. So x squared equals negative 4ay minus 30. Okay, so, and remember, in order to find the equation of a parabola, you have to know A. In order to find A, you have to have a point that's not the vertex. So if you start here and you scroll around, there's a couple points that you guys know, okay? So you could use this point. You guys know the coordinates of that, or you could use this point, okay? This one is 10, 0. This one is negative 10, 0. Okay, they both work. Use whichever one you like best, okay? I'm just gonna go ahead with the 10, okay? The positive one. So I'm gonna use the point 10, 0. Okay, so that means I plug in 10 for x, and I plug in 0 for y, and I get 100 equals negative 4a times negative 30. So 100 equals 120a. So a equals 100 over 120. Okay, if you reduce and divide, you get 5, 6. Okay, if you wanted to turn that into a decimal, you could, but it's not necessary. Okay, all right, so then to find an equation, you have to take that value and you have to plug it back in right there for a. So your equation is x squared equals negative 4 times a y minus 30. Okay. Or x squared equals negative 20 over 6 y minus 30 reduced. Okay, 2 goes into both of those. Okay, so if you notice, the parabola takes a lot more work. Oh, I'm running. Oh, sorry. Hold on. Okay, sorry about that, you guys. Okay, so again, to find the equation of an ellipse, use that equation, center is 0, 0. This one, parabola opening down, plug in the vertex, plug in an additional point. Okay, so now we have two equations, one for the ellipse, one for the parabola. Okay, it says which tunnel has more height 5 feet from the center. So, you know, if you were a truck, it would matter if you could clear it. So 5 feet from the center, is halfway. Okay, how tall is that? And how tall is that? That's kind of what they're asking, okay? All right, so I'm gonna have to move this up, okay? We're gonna do each equation, okay? All right, so let's break this up into two parts. Let's do the ellipse, and let's do the parabola. Okay. All right, so the ellipse, we have x squared over 10 squared plus y squared over 30 squared equals 1. And 5 feet from the center means x equals 5. So I'm just going to put the 5 in there. I get 25 over 100 plus y squared over 900 equals 1. So I just went ahead and squared those. To solve this, I'm just going to subtract this from both sides. So I'm going to get y squared over 900 equals 1 minus 25 over 100. Okay, so y squared over 900 equals 75 over 100. Okay, and at this point, you can just multiply by 900. And you get y squared equals. Now, you can keep working with fractions, but in reality, y is going to end up being some sort of decimal anyway. So it's totally fine if you just type in 75 times 900 equals divided by 100, and you get 675. Okay, square root that. And you get 25. Hold on. Second square root of 675. Okay. You get 25.981. Okay. All right. So that means that if you go 5 feet out, okay, you're going to get a clearance of 25.981. All right, feet. Okay. All right, in the next problem, in the parabola, okay, our equation is x squared equals negative 10 thirds, y minus 30. Okay. In this problem, you know that x is 5. It's right here still, so you get 25 equals negative 10 thirds, y minus 30. Okay, so at this point, if you're basically going to just divide by this. So you're going to do 25 divided by negative 10 thirds. If you use your calculator for that, make sure you do parentheses, negative 10 divided by 3, like this. Can you guys see that? Oh, it's a little glary. There we go. If you don't use parentheses, then the calculator will give you the wrong answer. Okay, all right, so you get negative 7.5. Okay, add 30 to both sides, and you get 22.5. Okay, so this is the height. Okay, so which one is better if you're a truck? Okay, obviously if you're a truck, you're going to want more clearance, so the ellipse is a little bit better. Parabolas tend to be a little bit steeper, so they can have, like, a parabola can have these 3 points and just like be a little bit steeper than an ellipse, which can have the same 3 points, but just tends to like kind of go out a little bit more like this. Okay, so they can share 3 points but have different shapes coming down, so the ellipse gives a little bit more clearance. Okay, I know this stuff is hard. We are going to actually practice it again tomorrow. Okay, so try your homework and email me if you have any questions, and we'll touch base tomorrow. Okay, take care, you guys. Bye.